Welcome to Emilak Online Tutorial. Now let us consider this question in kinematics in mathematics. Now a particle P is projected vertically upward from a point on the ground with initial velocity 40 meters per second. Now the question is, find the range of values of time t seconds for which the particle is more than 60 meters from the point of projection, and B, if after 1 second another particle Q is projected vertically upward from the same point with velocity 55 meters per second. Find the time the two particles meet. Now the distance of the point of their meeting to the point of their projection. Now maximum height attained by Q. And we are given that the acceleration due to gravity is 10 meters per second squared. Now let us look at it this way. From the diagram, now a particle P is projected. Let us assume that this is our ground. Now the particle, okay, now, and we are told here that the initial is 40 meters per second. Okay, so now at this point here, and we are to find the range of time, values of time t second for which the particle is more than 60 meters from the ground. Now let us assume that after projection, let's assume that at this point is our 60 meters from the ground. Okay, this is 60 meters from the ground, and in the same vein, also here 60 meters from the ground. So it means we have to calculate for this time when the object was thrown. Okay, now at this height, which is 60, now what time did it get here and what time did it get here also at the same 60 meters from the point of projection? So that's how we will this is the pictorial diagram for A. So how then do we calculate this? Okay, now let's use this motion equation. We say that S equals to ut plus at squared all over 2. Now since this is motion under gravity, our A then equals what? G, and this is vertically moving upward, then our A will now become negative what? G. So to that end, so we say S equals to ut negative G all over 2t squared. Okay, now the height is 60, then equals our initial velocity is 40t, then minus acceleration due to gravity, that will be 10, then t squared all over 2. So this equation on the left hand and right hand side becomes 40t minus 5t squared, because 2 here 1, 2 here 5. Okay, so to this end, so we can now say here that this is 60, then equals 40t minus 5t squared. All right, so we can rearrange. Now this will, if we are to rearrange, this will be 5t squared, then minus 40t, then plus 60 equals 12. Now dividing all through by 5, then this will give us t squared minus 40 divided by 5 will give us 8t, then plus 12. Now to this end, we will need to factorize. Now by factorizing, now what can we multiply? Two numbers that will multiply to give us positive 12, and that same two number, when we add it, it gives us negative 8, and that should be negative 6 and negative 2. So here you have t minus 6 and t minus 2. So to this point, we can now see that t minus 6 equals 0 and t minus 2 equals 0. So to this end we can now say this is t equals 6 and t equals what? 2 seconds. So it implies that as the object is being thrown, on getting here is at 2 seconds. Now moving over, on getting here is at 6 seconds. Okay, all right, so that's that. Then the next one here is B. Okay, and B here, what we just need to do here, if after 1 second another object Q is projected vertically upward from the same point, so from this point another object is being thrown. Okay, now find the time the two particles meet. Okay, let us assume after 1 second, the same point here, let us assume that this one Q, this is P here, now another one here. Okay, all right, so let us assume that this is probably where they will meet. Okay, and maybe this is the maximum height, all right, for Q. Now this is just an assumption and not the exact phenomenon or action. All right, so now the question now is, at this point they will have the same height, right? Where they meet here, they will have the same height. All right, so how then do we do this? Now I'm still using the same equation here. We have that for the first one, Q, P, now let us say 1 equals U1 T, then 1, then minus, since it's also vertical, then G all over 2 T square 1. Okay, now at this point too, let us now the height we don't know, that'll be okay, that'll be U for the Q is what, that is 40 T1 minus 10, so that will be 10 divided by 2, then T1 all squared. Okay, now let us say this equation 1. Now the second one, now take note, after 1 second, which means 1 will be subtracted from the initial time. Okay, so now the second one, which is the initial velocity of 55, then into bracket T1 minus 1, then minus, at this point this is 5, because 10 divided by 2 is 5, so that will be 5, then into, now T minus 1, T1 minus 1 all raised to the power of what? 2. Okay, now this is for equation 2. All right, now I want to, next thing here we need to what? Equate, because they are actually at this point where they meet are of the same height. So at this point here we can now say that 40, so you can see this h equals to what? H. So 40 T1 then minus 5 T square 1 equals, at this point here we have 55 into T minus 1 minus 5 into T1 minus 1 all squared. Okay, so at this point now we need to now to expand and simplify. Okay, so at this point, so let us see here, 40 T1 minus 5T squared 1 then equals, opening the bracket here, take note this is T1 also, that will be 55 T1 minus 55 then minus 5. Now opening this bracket here, T1 minus 1, T1 minus 1, so this will be T squared 1 then minus t1 minus t1 then plus 1. So here you have t squared 1 then minus 2t sub 1 then plus 1. Okay, now which means the whole of this expansion becomes t squared 1 minus 2t1 plus 1. Okay, now here we have 40 t1 minus 5t squared 1 then equals 55 t1 minus 55 minus 5t squared 1 then minus 5 times minus 2t1, we have plus 10t1 then minus 5. That is negative 5 multiplying through with what is in the bracket. Okay, so at this end let us collect like term. Now that we have negative 5t1 and negative 5t squared 1 and negative 5t squared 1. Now if you bring negative 5t squared 1 over to this, it definitely will cancel out. Okay, let me just collect like term so that we get to understand every bit of this calculation. Now be 40t1. Do you have any for t1 here? Yes, we have 1 here. We have 55 here. So bringing all to the left hand side, we have negative 55t1 and this one also negative 10t1. Is that all? Right? So then equals, now here we have, this is gone, is over to the left, the 55. Okay, now we have here 55 then minus 5, then I guess that is all. Okay, then we have negative t5 squared then here plus 5t squared. So this will eliminate this. So we are now left with 40 minus 55. That should give us a 15. That should give us 15. Okay, so that will be 40 minus 55. That should give us negative 15. And negative 15 take away 10. This will give us a negative 25. Negative 25 t1 then equals, here we have negative 60. So dividing both sides by negative 25. So and this should give us 60 divided by 25. That will be 2.4. So our t equals 2.4 seconds. Okay, so at the point which here they meet, the time is 2.4 seconds. Okay, all right, now let us now calculate for the distance of the point of their meeting. The distance of the point of their meeting. All right, so can we quickly do that here? All right, so now still making use of the equation we've been using, that is for B2. Okay, so here we have that h equals to 40 t1 then minus here 5 t squared 1. Okay, now plugging in the value of t1 to ascertain the height. So here you have that h equals to 40 into 2.4 then minus 5 into 2.4 all raised to the power of 2, and 2.4 raised to the power of 2, that will be 5.27. I hope I'm correct. Power calculator 2.5 raised to the power of 2. Now times 5. Okay, 28.8. Now this is negative 28.8. Now 40 times 2.4 will give us 96. So our h here now, 96 minus 28.8 should give us 67.2 meter. Okay, all right, so that's the answer. Now we'll move to B3, the maximum height attained by Q. All right, so to this end, now take note, the maximum height of Q, which is here, it implies that here at this point V is 0. Okay, because at this point it is stationary. Okay, so we'll be making use of this equation. V squared equals U squared now plus 2AS. Now let us recall also that our A here equals to negative what? G. Okay, so and our V equals 0. Okay, so here we have 0 equals our U here is that will be 55 squared, then minus, take note, our A here is negative G, so this equation becomes V squared equals to U squared minus 2G then H. Okay, so to this point here now, we have 2 then times 10 times H, which is the maximum height. So here we have that 55 squared. Now this should give us, this will be 0 equals 3025 then minus 20h. Okay, so after which, bringing negative 20 over to the left hand side, you have 20h equals 3025 divided both sides by 20. So our h, dividing it here, calculator, so here we have 151.2 meter. So this is the maximum height at this point of Q. Alright, if you love what I've just done, subscribe to my YouTube channel and ensure you click on the equation button to be notified of all my videos in physics and mathematics. Thank you and God bless you.